All right, number 20. So this one is hard and kind of not much to do at the same time. Typical SAT problem. So we want the value of sine of ABD minus the cosine of DBC. So first of all, this you can't do opposite over adjacent for the sine of this because this is not even a right triangle. And then same thing with cosine here. The concept is the point of them giving us this is to tell us that the two angles that we're trying to find the sine and cosine of, they add up to 90, which means they're complementary. And any time you have two angles that are complementary, the sine of one is always equal to the cosine of the other. So therefore, when you subtract them, you're just going to get 0. Now, to further explain why that is, just imagine we had an actual right triangle. All right? And I looked at this angle was my, one angle, and this was the other angle. If I wanted to do the sine of this angle, that would be the opposite, let's just call this A, over the hypotenuse, let's just call that C. And if I switched over and did the cosine of this, well, the adjacent would just be this same side, which was the opposite for the other angle over the hypotenuse. So you would always get the same answer because you're just flipping to the other angle. So in general, it just means any time two angles add up to 90, then the sine of one will equal to cosine of the other. Just try it in your calculator. Do like the sine of 70 and the cosine of 20. Or do the sine of 50 and the cosine of 40. They're always going to be equal to each other. So therefore, this problem really is just seeing that and realizing that, well, no matter what they are, when I subtract them, I'm going to get 0. Hard problem, though. Really hard problem, I think.